Graphing quadratic functions. I want to start with y equals x squared. That's just what we call the parent function of all quadratic functions. So every other function is just a transformation of this function. So what we're concerned with, of course, is the solutions. So you can make a table and list some solutions. Let's start with, we'll do some negatives and some positives. So -4, if you square it, you get 16. -3, if you square it, you get 9. -2 squared is 4. So these are inputs and these are outputs. You can plug in anything you want. -1 squared is 1. 0 is 0. 0 squared is 0. And then the positives, 1 squared is 1. 2 squared is 4. 3 squared is 9. And 4 squared is 16. And I can go on forever and ever. So my domain, the numbers I can plug in, are infinite. I can plug in anything I want. I can plug in 100 and then square it. So every input has an output. So these are the solutions, and that's what we're concerned with, is solutions. That's everything in algebra, is the solutions. And the graph is just a representation of all these solutions. So we graph them. 0, 0 is, let's do this in another color. 0, 0 is here. 1, 1 is here, and -1, 1 is here. 2, 4 is here, and -2, 4 is here. So this thing has what we call symmetry, meaning that this side looks exactly like this side. If I plugged in -3, I'd get 9, which is somewhere up here, and +3 is 9. So it just has a mirror image on each side, and it goes on forever like this. And don't forget, we put the arrowheads to show that there are more solutions. It keeps going. We're stopping there because that's as far as we can fit on the graph. But this shape is called a parabola. So this is a quadratic function. The graph of its solutions are in the shape of a parabola. The parabola has symmetry, where the right side matches the left side. This point here is called the vertex. Sort of the most important point. When you're graphing, you start here, and you can just, really, you could just list solutions on one side, and then you know the mirror image on the other side is exactly the same distance from this axis. So this is 2 steps to the right, 2 steps to the left, 1 step to the right, 1 step to the left. So it has symmetry. It's symmetrical. One side matches the other. This point is called the vertex, and the shape is called the parabola. And I just want to look, so this is the graph of this function. This is the parent function. Everything else that we look at for the remainder of this section is going to be a transformation of that. So if I just said, well, let's look at the same function, but this time let's call it y equals x squared plus, let's say -4. Well, I'm still making a table of solutions. You're still doing out the math. You could plug in -4 again and square it. You get 16. -4 is 12. -3 squared is 9. -4 is 5. -2 squared is 4. -4 is 0. -1 squared is 1. -4 is -3. And 0 squared minus 4 is -4. And the same thing's going to happen if you plug in 1 and you square it. You're still going to get the same thing as you got here. 1 squared is 1 minus 4 is -3. So I'm going to get all the same solutions here, 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 here. So if I plug in +2, I should get 0. So the solutions look like this: 0, -4, 1, -3, or -1, -3, -2, 0, +2, 0. So we have that symmetry going like this. This is my vertex at -4, 0. Symmetrical on both sides. Same shape as the original function. The only difference is it's shifted 4 units down, and we call that a vertical shift. Meaning I took the original function, y equals x squared. I made it y equals x squared minus 4, and my graph just shifted 4 units down. It looks exactly the same shape, just shifted 4 down, and that's called a vertical shift, and that's a transformation. That's a transformation of the original parent function. Okay, and I think maybe very quickly here, where am I at, 5 minutes? If I did y equals x minus 4 squared, this is different. That's a different kind of transformation. If I make a table, if I plug in 4 minus 4 is 0. So I have this point 1, 2, 3, 4, 0. If I plug in 5 minus 1 is 4, 5 minus 4 is 1, 1 squared is 1. So I get 5, 1. If I plug in 3 minus 4 is negative 1 squared is 1. So I get 3, 1. If I plug in 6 over here, 6 minus 4 is 2, 2 squared is 4. So I get 6. 1, 2, 3, 4. If I plug in 1 minus 4 is negative 3 squared is 9. I get the same solution. I get, oops, I missed something. If I plug in 2 minus 4 is negative 2 squared is 4. So I have 2, 4 here. That's the same solutions. So now I have the same shape that I had before. This is a parabola. This is my vertex at 4, 0. So it's the same shape, only now it's shifted to the right. So this is called a horizontal shift. And it's a little tricky because you see when we did x squared minus 4, we shifted down, and that makes sense because you're subtracting and you're going down. In this case, even though it's x minus 4 squared, you actually went to the right 4 units this way. So when it's minus 4, you move to the right. When it's plus 4, you move to the left. And the reason is because when you plug in 4 minus 4 is 0, so your vertex ends up here. So this is a transformation, so horizontal shift. So that's it for this video. I just wanted to show you the original parent function, which looks like this, and then I wanted to show you a vertical shift downward, and that's represented by subtracting 4, and then a horizontal shift with parentheses, x minus 4. So this one's x squared minus 4, this is x minus 4 squared. Okay, so we're going to talk more about these transformations going forward and combining different transformations together.